What's going on, everyone? Welcome to part 2 of our brand new project, which is a live emoji. And if you don't know about this project, let me show you a quick intro. So it is predicting smile, good luck, nope, hello, smile. So how's it? Pretty interesting. So we have already covered our part 1, which is the data collection part. If you haven't seen that, I would recommend you to go and watch that, but it is still okay if you want to follow along with this part. You can actually watch that part after watching this video. So let's start this video quickly, and in this video, let me tell you, we are going to finalize this project, which means that we already have collected our data, and now we just have to load that train that data, and then run the inference on that. So we are going to create 2 Python scripts in this video. First is for training and the other one is for doing the inferencing. So let's start, shall we? Alright, so here we have our data collection part. So let's create our first script, which is data training. I will just call this data training.py, and we will also need another script, which is inference.py. We are going to code this later on, but first we will focus on the data training.py. Let's open this with whatever text editor you use. Let me just take it to this screen. Alright, so here we are. Now let's do that. Before starting this video, we actually need some data. Actually, let's just run the data collection.py file 2 or 3 times and collect some data. So I'll just open the terminal in the same directory and I'll say python data collection.py and I'll just run it. And let's say I want to give the data for hello emoji. So I'll just say this. Alright, so we have collected data for hello. Let's do for good luck. Let's give the name good luck. And let's just give for, let's say, nope. Alright, so I guess this should be enough. Let's close this terminal. Now we have our goodluck.npy, hello.npy and nope.npy. We have 3 data over here. Now let's start. So first of all, we are going to use OS module for getting the files in this script, and then I guess we also going to use numpy as np. Let's just import cv2 also in case we need that. I guess that's all we need for now. And now let's do this. So first of all, we are going to search for all these files, which is goodluck.npy, hello.npy, nope.npy in the same directory. So for that, we have the function called list_dir directory in the OS module. Let's just see what this return, and we'll say for I in os.list_dir print I. So let's just open the terminal in the same directory and run this script, which is called python data collection training. So you see that this is returning data training all the files in the same directory, but we are interested in only the files which end with the extension .npy. So it is very easy to filter out those files. We'll say if I.split at dot, and this is going to return a list, and we are interested in the last element of the list, and that if that last element is .npy, if it is npy, then we're gonna say that this is the file we are interested in, right? So what to do with that file? Of course, we want to load it by using the numpy. So how to load it? Now there are some ways of loading the file. First one, we will create our x. Okay, just leave it. We'll just say init is init. We'll just initialize it as false. So initially, we are going to initialize the x and y data variable, or to create the array. Once the initialization is completed, we are going to just concatenate the new files, the upcoming files, into that previous loaded file. Let me just quickly show you what do I mean by that. So first of all, we're gonna say if not is initialized, we'll say is initialized is equals to true. Now we are going to initialize it. So we're gonna need x array, which is going to be our input data. So we're going to say x is equals to np.load that file, particular file. Very easy, nothing too complicated in it. Now we also need y. So what will be the y? Y will be obviously going to be the label associated to that data. For example, if we are talking of nope.npy or goodluck.npy, the all the data inside goodluck.npy will going to be my X data, which will be input to my model. And for that particular input data, I want my model to predict something. And what I want my model to predict is good luck. Obviously, you agree with that or not? So we are going to have that data inside the Y variable. So how to do that? We are very easy. We'll say np.array. Now how much the size of the data? The same size we want of Y. So we'll create a variable, let's say size. Initially we will set it to -1. Then we will initialize it over here. Size will be x.shape, and we are interested in the 0th part, meaning the number of rows we have, right? So the size will be x.shape 0. And now in this we will create an array of i.split. Let me just first write that code. i.split at 0, and the 0th part, which means we are going to split at dot, which is goodluck.npy. Now the list will contain goodluck and npy. We are interested in the 0th element, which is goodluck, right? Now this is a list of only one variable. We are going to multiply it by the size. Whatever the size of x will be, the same size of y will be. Okay, I guess this is enough. Yeah. So once the initialization is completed, meaning we have loaded our first data sample, now we are just going to concatenate in this x and y, which is going to be the same process after all. We'll say np.concatenate x and the new data we are getting, which is obviously np.load I. Yeah, do you agree with that or not? Similarly, we will say y is equals to np.concatenate y comma np.array. The same thing over here. I hope this should work. If we get any error, we'll just resolve it. Yeah, I guess everything looks fine over here. Now we'll just, to make sure everything is loaded perfectly, we'll just print the shape of our x and y. So we'll say print x.shape, y.shape. Let's just save this and quickly run this. We got an error, line 5, integer, scalar. Let me just see. Yeah, so this need to be in past int tuple. In np.concatenate, over here we are getting the error. Yeah, so let's run this once again. We have the size is 300 rows and 1020 column of our x and 300 rows of y. Let's do one thing. Let's reshape this to -1, 1, and similarly dot reshape this to -1, 1. Let's run this once again. np.array. Wait a minute. This have to be over here. Let's run this once again. Yeah, so everything looks fine over here. So we had our, okay, so over here we have loaded the data. Everything looks fine. Let's just try printing our data x and printing our data y. Let's see how the data looks like. So x looks good over here, right? We can directly send x as the input, but y doesn't look good over here. You see that we can't directly send the y as it is. This is string, but the model needs the data to be in integer or float. The model can't work with string, so we need some way to encode this, convert this string to some sort of integer if we can, which is very easy to do. We will just create a list of labels over here. Let's just call this label, and let's just create a dictionary also. You will see why we need that. And let's create a flag variable c to 0. So what this dictionary will do, every word or data sample, which means good luck or nope and hello, so every word will have a unique integer associated to it. So for example, hello will be 0 and nope will be 1 and good luck will be 1, 2, and later on we will just convert those strings to their particular identity, unique integer associated to them. And if required, we can just re-encode them when we are making the prediction from our model. So that's why we are using this label over here. So I hope everything makes sense to you. Let's just come over here. Yeah, we'll say label.append. What we want to append, just try to pause the video and make sure you can guess what we want to append. Obviously we want to append this, so we want to append this. And similarly, let's do the same with dictionary this particular word will have C variable, and we will increment the C to +1. Yeah, that's it. Now let's try printing our dictionary, and similarly label, see if it is doing or not. Yeah, good luck has 0, nope has 1, and hello has 2, and this label is also the same. Okay, so now we have the dictionary over here, and now we need a way to convert this particular, where is this? Yeah, we want to convert this y to the integer, so which is very easy to do. We'll just iterate in for I in range, the length, the size of our y data. So we'll say y dot shape 0, and now we want to convert that particular y, so we'll say y at that ith row and 0th column, obviously, which will be equals to dictionary. The key to that dictionary will be yi0. Okay, so let's try printing before encoding and after encoding. Yeah, we have done it successfully, you see that, but the only problem I see that it is a string. We want it to convert to integer, which is very easy. We'll say y is equals to np dot array y, and we'll just change the data type to int32 or whatever you want. Let's save this and run this once again. Yeah, that's it. Yeah, I think everything looks fine, but still there is one thing we want to do. What is that thing? Let me just explain you real quick over here. Let's just do the commenting over here. Okay, so you see that we have encoded, let's say hello to 0 and let's say nope to 1, but if we talk of integer, 1 is greater than 0. Yeah, you agree or not? But nope is not greater than hello in any way. These are two different words having two different meanings, but you can't compare them with any quantity. So we can't say that nope is 1 and hello is 0. When we train our model, for our model, this might have more precedence, or this might have the lower precedence, or vice versa, but that we really don't want that. So what can we do? What can we do to solve this problem? Very easy. You see, when we are pointing to 0, we'll create a 2D array. When the index is 0, the value is 0, we'll say 1, 0. When the 1 is there, we will turn the first index to 1, like that. So how to do that? Very easy. There is a function in TensorFlow.keras.utils import to categorical. Still it doesn't make sense. Just wait a minute, I'll just show you what do I mean by that. So over here, let's just print the y.shape. Let's get rid of these print statements. Okay, so now over here we'll say y is equals to categorical y. Yeah, that's it. And now we'll again print the y.shape like this. Let's run this. You see what did I meant by that. Okay, so this is what I was talking about. You see that initially the y shape was just single column, and later on we converted that single column to 3 columns. Yeah, do you see that? What did I meant by that? Okay, let's just try printing the before y and after y. Let's save this and run this once again. Okay, so you see that over here, when we have the index as 2, then let's talk about last. So the second index is turned 1 and everything else is 0. Similarly, when the index is 1, the first index is turned 1 and everything else is 0. When the value was 0, first 0th index was 1 and everything else was 0. So that is what I was talking of. Now everything looks fine. We can just directly send our data to the model, and we can create the model, obviously, first of all. Then we can send this our x and y to our model, and we can train our model. So what do we gonna need for making our model? Obviously we're gonna need some layers. Let's quickly import them from keras.layers, import input, and we're gonna need a dense layer. That's it. And also we're gonna use functional API from keras.models import model. That's it. Let's create very simple model, since the data is not pretty big and the work is also very simple. So we're gonna just need very simple model. So we're gonna say input, first layer will be the input layer, IP, we'll call this IP. Input, it's gonna need the shape, the shape is going to be x.shape, and it doesn't have to do anything with the number of rows we have. It only have to do with the number of columns we have. So x.shape 1. Let's create the middle layers. We'll say what do we call it? Let's call this M, dense, and number of units, let's say 512. Activation, let's give it activation of ReLU. Let's connect it with the previous one, which is IP. Let's copy this, and it have to be connected with the previous one, which is M, and change to 256 neurons. And let's create the output layer, which is going to be again dense layer. The number of units over here we have, this is important. Just a 10. Just look at over here. So you see that in the output we want 3 neurons, meaning output neuron which is making prediction associated with the 0th index, 1st index, and the 3rd index. So over here, what do you think we should pass? Obviously y.shape. This time the first, meaning the number of columns we have. The activation, can you guess which activation gonna use? Softmax. Why softmax? Because sorry. So because we want every neuron having the probability associated to it, probability of being 0th class, probability of being 1st class, probability of being 2nd class, and when all of these 3 summed up, they're gonna sum up to 1. So that's what we are interested in, and we're gonna connect this output with the previous middle layer, which is M. Okay, now we'll finally create the model. We'll say model is equals to model. Inputs will be IP and outputs will be OP. Very simple and straightforward model. Nothing much have to do in it. Now we'll compile our model quickly with the optimizer as RMS prop. Let's just leave it over here. And loss will be categorical cross entropy. Why categorical cross entropy? Simple, because we have the categorical data. And finally we have to give the matrix. We'll just give accuracy, ACC. Yeah, now we'll just fit our model.fit on X and Y and number of epochs. Let's just give 50 epochs. And yeah, let's just save it and see if everything is working fine or not. Let's just train the model and fingers crossed and see if everything works fine or not. Yeah, everything is working pretty fine, and look at the accuracy and the loss, it is reducing. Yeah, everything looks good. But there is one thing I want to talk about. Let's just, I'll just cut this out for a moment. Model.fit statement, I'll just comment it out. And I want to show you something. If I print my Y, let's just print from here. So you see that when we are training our model, first of all, it is trained on the 0th class continuously, then the 1st class continuously, then the last class continuously. So I think that this creates some problem while training our model. Our model first learn about hello, 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 hello. Then our model learn about nope, 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 nope. And then our model learn about bye, 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 and so on. So this is just creating some type of cluster type of thing, I would say. So it would be nice if we just shuffle our data. If we shuffle our data, then it would be, our model would be able to predict the things very effectively. So how can we do that? Very, very, very easy and tricky method I have. So we'll just create the copy of our X and Y. We'll just say x.copy, and similarly I'll just create Y new and I'll say Y. So we will have a let's just create a counter also. You'll see why we need that. So let's just create a CNT. Yeah, so we'll create a CNT. This is going to be np.arrange x.shape, meaning the number of rows in the X will be equal to the number of rows in Y. So you can use whatever over here. X.shape zeros the number of rows in X. So what this function return, let me just show you quickly, real quick. Numpy as np, and what I am doing, I am saying np.arrange, let's say 50. So you see that this function returns a list of all the counting from 0 all the way to 49. So that's what we are interested in. We are storing in CNT, and then later on we are saying np.random.shuffle that CNT. So this shuffle function will going to shuffle all these values from 0 up to 49, shuffle all the values from their places. Now over here we'll just iterate in for I in C and T. We'll say x new at that counter position, meaning at 0th position, will be x I, that particular shuffled value. Yeah, I hope you are getting what I was doing over there. Y new again at that counter position, because we don't want to lose our data. Y new at that counter position, we will say y I, and then we will update the counter. I really want that Python please add the support of counter plus plus directly, doing such in C++, but we have to do this counter plus 1. Yeah, so that is what I was talking of. So now if I print my y and print my y new, then you will see that we have our shuffled data. Let's just quickly run this. Okay, so now you over here see that this was my previous y, which is the continuous, and now we have the random samples. Yeah, that is what I wanted to be. Now our model will be pretty much very accurate to predict the things. Let's just save our model real quick by saying model.save so that we can load in the inference part. We'll call it model.h5. And one thing I really want to save is np.save. You can see why we need that. np.save labels.npy, and the array will be np.array label. You'll see why we are saving these labels, but you might know that you can guess why we are saving this labels.npy. Let's just save this and run this real quick. Alright, so the training is completed. The loss is this, the accuracy is this, and let's see if model.h5 is saved, labels.npy is saved. That is what we wanted. Now let's quickly load this inference.py file. I also want this data collection py file. Now at this point I would recommend you to open this part 1 and try understanding this, because I'm going to use the same code from there, because I don't want to repeat myself writing again and again the same code. You can watch the explanation of this part over here, because already this video is being so long. Just leave it. I'll explain you, don't worry about that. Okay, so how to start from here? Look, we have the model, so we'll just import the CV2. We're gonna need that, I know. We're gonna also need numpy as np. We're also going to use mediapipe as np, and we want to load the model obviously from keras.models import load model. Yeah, that's it. Let's first quickly load the model. So we'll say model equals to load model and pass the name and load the labels also. So we'll say labels equals to, I'll just call it label, np.load labels.npy. Yeah, that's it. Now as I said, we are first going to use the same code. I'll just quickly copy this. Don't worry, I will explain to you. So what is this? This is again, if you want line by line, character by character explanation of this code, please go ahead and watch the part 1. I'm just going to be real quick explaining you this. So over here we are using the holistic solution for the prediction of the post prediction given to us by mediapipe. Very easy, nothing too complicated in it. And over here we are creating the object of this holistic class from this holistic the type of reference we made over here. This is the hand solution provided by mediapipe for the landmark prediction of hand. This is for creating the visuals, the solution provided to us by mediapipe again. Now I will just going to use this cv2.video capture to capture from my webcam directly. Save this and let's just do this magic over here. I'll just copy all of this. Okay, so this is the true loop, this is my true loop, this is my list lst, just list, and over here I am reading from my camera, which is I have created over here. I have flipped the frame, I don't want that mirror look, and then I'm going to use this holist object which I have created, initialized from this holistic class. This holist object can process the frame, but that need to be in RGB format. So I have used CVT color to do that, since CV2 reads in BGR format. Now I'm checking if this Hollis object or mediapipe is able to find any phase in the frame, which is checked by using this line, then follow along with this code and then else do nothing. So if there is someone in the frame, just iterate in it. So we can iterate result.faceLandmark.landmark. This is going to return a list and I am iterating it in it and then storing my x and y value inside the list, not directly but by subtracting from the reference point. I have already explained in part 1. You can go and watch that part 1. Again, I am checking if the left hand is in the frame, just store it in the same way we have stored for face. Otherwise, just store 0 in place of that. Similarly, if right hand is in the frame, just store it by subtracting from the reference point. Again, why we are subtracting, I have explained in part 1. You can watch that part 1. Otherwise, just store 0, 0 instead of that. Okay, so we don't need this line over here. Don't worry about that. We also don't need this line over here. That's it. And over here, we are just using this drawing over here, which we have created there. We are using this to draw on frame. What we want to draw are the predictions, the result framework. And then over here, we can also remove this line. We don't need that. Yeah, that's it. That's all we wanted. Now it's just matter of converting that LST to our array. So we'll say LST is equals to np.array LST, and we're gonna reshape it to 2D array since this is a 1D list. So to reshape, we'll say 1, -1. If you want to know what this line mean, np.reshape 1, -1, -1, 1, you can watch my previous video. I have explained in that. I will link that in I button. So this is my LST. Now it is just matter of doing model.predict LST. That's it. Let's try printing the predictions over here. Though it will not going to make any sense, we'll just use the labels which we have saved over there. We are going to use labels to convert that to human readable thing. So we'll say Python inference.py. Hope we got no error. Yeah, we got error. Data size. Okay. So we want to remove this. Since we have copied from the previous script, obviously we are going to face some error. Yeah, it is running perfectly fine. And over here we are getting the predictions from our model. Let's escape it. To get the max prediction, we are going to use a function given to us by numpy, np.arg. Very easy and straightforward, nothing to explain. So this is going to be my maximum index with the prediction, and I can convert that to a string by using my label array which I have saved from my previous script, right? If you remember. So yeah, this prediction will contain that. Let's run this now. So yeah, this is returning good luck. Obviously it have to return anything. So let's try giving hello. Yeah, it is returning hello. Let's give good luck. Let's give nope. Everything is working fine. Let's just do one thing. Let's use the put text to put the prediction on the frame instead of reading from the terminal. Let's copy and save. Label, he'll just use directly prediction. Let's save this now and run this. Hello, good luck, nope. Yeah, you can add as many expressions you want to add. Okay, so yeah, you can add whatever expression you want to add. Why won't we do that? So again, I'll just add new expression. Let's say Python data collection. This time I'm going to add the expression for smile. Okay, so we have added the expression. Let's run Python data training.py. Let's run this. Yeah, I guess we're gonna get an error. Yeah, so you see that we are getting the error. Why we are getting the error? Because over here we have labels.npy. This is not our data. This is a labels.npy. So somehow we need a way to ignore this labels.npy, which is not too much difficult to do so. We'll just say we'll come in data training part, and we're gonna say if the file is npy and the file is not 0th index, obviously, and the file is not labels. Save this and run this now. So it is going to do the training part. Yeah, training is completed. Let's run the inference. So it is predicting smile, good luck, nope, hello, smile. Everything is working pretty fine, and I would like to end this video over here. If you still have any queries, any doubt regarding this project, you can directly ask me in from down comment section. If I know answer for that, I will reply. If anybody else know answer for that, please reply to that comment made by that person over there. So that's it for this video. If you really enjoying my work, please make sure to give this video a thumb up and stay tuned for the more upcoming videos, because I have planned so amazing content for you similar to this. So that's it. Bye. I will catch you in the next video.